Hey everyone, and welcome. Today, we're diving deep into a design pattern that powers some of the most responsive and massive apps you use every single day, event-driven architecture, or EDA for short. So how does it all work? Let's get into it.
To really wrap our heads around this, I want you to start with a simple question. What if your software wasn't a rigid, top-down set of commands, but, well, something a lot more social and dynamic, kind of like a big party?
So picture this. You're at this party. Instead of the host running around telling every single guest, "Hey, the cake is ready. Hey, cake's here," they just ring a bell. That sound goes out to everyone, but who reacts? Only the people who actually want cake, right? Everyone else just keeps on dancing. That simple, brilliant idea, that's the heart of an event-driven system.
Okay, so let's translate that party into tech terms. The official definition is that event-driven architecture is a design where different parts of a system communicate by producing and responding to things called events. And an event is really just a signal that something important happened. A user clicked a button, a sensor reading changed, an order was placed. The whole system is built to react to these things as they happen.
All right, so here's our game plan. We're going to cover exactly why this matters. Then we'll break down the core components that make it tick. After that, we'll look at some real-world use cases and, of course, finish up with the challenges you need to watch out for.
So, what's the big deal? Why do developers get so excited about this approach? Well, its power really comes down to a few major advantages. First up, scalability. And this is a huge one. Because all the different parts of the system are independent, they don't even need to know the others exist. You can add or remove them without breaking the whole thing. Need to handle way more notifications? Cool, just spin up more notification services. This makes it incredibly easy to grow and adapt your system when demand spikes. Next, it is all about speed. Events are handled the very moment they happen. This makes EDA absolutely perfect for any app that needs to react instantly. We're talking about processing financial transactions, updating live sports scores, or reading data from an IoT device. The system is always on, always listening, and ready to spring into action. And finally, flexibility. The components are what we call loosely coupled, which is just a fancy way of saying they aren't tangled up with each other. This is so clever because it means you can update one part of your system without needing to rewrite everything else. Maintenance becomes way easier. So we know it's scalable, it's fast, and it's flexible. But what are the actual moving parts that make this whole thing work? Let's meet the key players in this architectural drama.
An event-driven system really boils down to 5 core elements. You've got the publisher, which creates the event bus, which is like a central highway for all the events, the subscriber, which listens for the specific events it cares about, the event itself, which is the message, and the event handler, which is the code that actually does the work. Now let's see how they all play together.
So here's the journey from start to finish. First, the publisher creates an event. Let's say order placed. Second, it shoots that event out to the central event bus. The bus then acts like a traffic cop, routing it to any interested subscribers. Once the subscriber grabs it, its event handler takes over and does the actual processing. It's a clean, one-way broadcast. Fire and forget. And this brings us right back to our party. The publisher? That's the baker ringing the bell. They just shout out, "Cake's ready!" They have no idea who's listening, and frankly, they don't care. The subscribers? Those are the guests who love cake. They're specifically listening for that bell, and they only react when they hear it.
This all sounds great in theory, but where do we actually see this architecture in the wild? Well, the answer is pretty much everywhere. This architecture absolutely thrives in high-volume situations, just like the ones you see here. E-commerce platforms, massive networks of IoT sensors, financial trading systems, they all generate a crazy number of events every second that have to be processed reliably and in real time. Let's make this super concrete. Think about the last time you bought something online. That single click, place order, creates an order-placed event. Now that one event gets picked up by a bunch of different subscribers all at the same time. The inventory system hears it and immediately deducts the item from stock. The shipping department hears it and starts the packing process. The finance system hears it and processes your payment. And the best part, all of this happens in parallel, and none of those systems need to know anything about each other. Now, before we wrap things up, it's really important to clear up a common point of confusion. You might hear EDA mentioned alongside a term that sounds kind of similar, so let's quickly set the record straight. The big difference really comes down to intent. Think of event-driven like a public service announcement. Hey everyone, just so you know, an order was placed. Anyone who cares can listen in.
Message-driven, on the other hand, is more like sending a direct letter with specific instructions. Hey, shipping department, I need you to process this order. So EDA broadcasts facts about what happened, while message-driven is often about direct commands.
Now, as powerful as EDA is, it is not a silver bullet. And like any big architectural choice, it comes with its own set of challenges and trade-offs that you've got to understand.
Because everything is decoupled and happening on its own schedule, just managing the flow of events can get pretty complex. It can be really tricky to guarantee that events are processed in the right order. And debugging? That can be tough, because you can't just follow a single request from start to finish. You're tracing a path across multiple independent systems. And yeah, while it enables real-time response, there can be a tiny delay, or latency, between an event happening and something actually acting on it.
So if there's one thing to take away from all of this, it's this right here. EDA is a fundamental mind shift. You're moving away from a traditional model of ask for something and wait for an answer to a model of sense something and react to it. It's about building systems that are constantly aware and responsive to what's happening around them.
And that brings us to the end. I'll just leave you with this one question to think about. As you look at the software and the processes all around you, where could this reactive, event-driven approach unlock brand new possibilities for more scale, more speed, and more flexibility? Thanks so much for watching.